Okay, our next problem is Chapter 2, Problem 6. And this one has a graph that I will draw in just a moment. And it basically says that we have a particle that starts at x equals 10 meters and at t naught equals 0 seconds. So basically our beginning position is 10 meters. So I'm going to put that down. And our beginning time is t equals 0 seconds. Okay. And it says it moves with the velocity shown in the graph, which I'll draw in just a second. And then it asks, does this particle have a turning point? If so, at what time? And then what is the object's position at 2 seconds and 4 seconds? Okay, so the other thing that we're given is this graph. I'm going to go ahead and write this stuff in here quick. So this is the velocity, not the position, okay? And then our horizontal axis, of course, is time. And that goes from 1 to 4. And then our velocity graph, which I think our book likes to put the velocity graphs in green and the position graphs in blue, so that's just a little bit of a hint for you. It's going to go up like that, okay? So the first question we have is A, is there a turning point? And in this case, we can say, yes, there is a turning point because at time t equals 1 second, the velocity goes from negative, meaning it would have been moving to the left, or negative x-axis, to it goes positive, so it's going to turn around at 1 second and then start heading to the right because its velocity becomes positive. Or if you want to think of it this way, it was initially going down and it's going to turn around and go up, okay? So that's yes, it has a turning point. Okay, that's the first part of the problem. The second one says, what is the object's position at 2 seconds and 4 seconds? Now to find the position, we want x final, and we're going to say that we want x final at 2 seconds. And remember, this is equal to the initial position plus the integral of the velocity. And our initial time here is going to be at time t naught, or 0. And our final time is going to be 2 seconds. Okay? So the final position at 2 seconds is equal to the initial position, which is 10 meters, plus, we've got to integrate, except we have a linear function, and if you remember what I talked about in the previous video, the linear function means that we can just take the area of the triangles. So we can take the area between the horizontal axis and our function. So I'll use red to kind of denote that. So up until 2 seconds, that's going to be this area plus this area, okay? So one thing to note is that the area of one of the triangles, let's go with the first one. So the area from 0 to 1 second is going to be 1/2 base times height, okay? The base in this case is 1 second, and the height is minus 4 seconds, okay? So that means our area is going to be equal to, oops, sorry, that second one should have been meters per second, not seconds. That means our area that's being given is equal to the distance it would have traveled in a certain amount of time. And so that's going to be equal to minus 2 meters. So we're going to go back and add this here. This is basically, this is our, whoops, sorry, I don't want to add quite yet. That's the first triangle, right? Well, the second triangle is going to be negative a, because it's basically got the same area, but it's above the axis, so it's going to be positive 2 meters, which means that our total area, or our integral, ends up being equal to 0 meters. at 2 seconds, okay? So that means at 2 seconds, our position is 10 meters, which is what it was before, okay? Now at 2 seconds, or sorry, at 4 seconds, we want to do this calculation again. We're going to do our initial position plus our change in position. And again, we don't have to integrate because it's a triangle. We can just calculate the value. So x of I is going to be equal to 10 meters plus, I'm going to break this into two parts. We know that that first triangle below the x-axis between 0 and 1 is equal to minus 2 meters. So I'm just going to put minus 2 meters. And then the area of the other is going to be 1/2 the base. Well, the base goes from 4 to 1, so the base is going to be 3 seconds. And then it goes from a value of 0 up to 12, so that means the height, the max height, is 12 meters per second. Okay, so we still have the 10 meters here. Actually, we can we'll simplify this in a couple steps. The 10 meters plus the 2 meters minus 2 meters is 8 meters. So that takes into account these two. Plus, well, 1/2 times 3 times 12. In my head, I'm going 1/2 of 12 is 6. Times 3 is 18. So we'll have 18 meters. So the final position at 4 seconds is going to be 26 meters.